So now I'd like to take a second look at review for Graphing Math 10. And in this case, I'll focus on our second big idea, which is slope. So I've already reviewed a little bit about analyzing graphs. And slope came up when we analyzed graphs because we were looking at linear versus nonlinear functions. So I'm going to kind of start there. Here you'll see in this table that we have a series of points. And so I'm going to just plot these points onto our grid. You've got the point 0, 0, 2, 3. Remember, it's the x-coordinate, then the y-coordinate. 4, 6. And finally 6, 9. 6 over, 9 up. So let's just stop for a minute and do a little bit of review. Right now, this is discrete because we have individual points and we do not have the formula. Now we're going to change that in a couple of minutes, but even though it's discrete, these points are still in a line, so it's linear. Because it's discrete, we would list the domain and range as a set of numbers. So the domain would be x belongs to the set of, and now I'm just going to take the x-coordinates. 0, 2, 4, and 6. The range is, because it's discrete, just a simple list of the y-coordinates. So 0, 3, 6, and 9. Now let's just stop it because we're supposed to be focusing on slope and talking a bit about slope. You'll notice that slope is also called the rate of change. And in math, when something changes, we look at the difference in it. So let's go back to the table here and look at the difference in these two y-coordinates. It's 3. Look at the difference between those two y-coordinates. And look at the difference between those coordinates. All of these points have the same difference. If you look on the graph, you'll notice that the vertical difference, which we call the rise, is 3. The horizontal distance is called the run, and this is the difference of the x-coordinates. And again, if you look over here, if I subtract those two x-coordinates, or if I subtract those two x-coordinates, I get a run of 2. Now if you look at these 4 points, every set of points has a rise of 3, a run of 2, a rise of 3, a run of 2. So now we're going to stop for a sec, and again, if I didn't have the equation, I would leave this as discrete, linear, separate domain and range. But now let's say I want to actually find the equation. Of course, once I have the equation, then now I'm allowed to use decimals and fractions, in which case I'll connect this and we'll end up with, instead of a discrete set of points, we'll end up with a linear function. Just before I find the equation, let's review again what slope is. And so we found that the slope of a line, which we use as m, is the rise over the run. So that's the definition for slope. Notice we've also said that to find slope, you could subtract the y-coordinates, subtract the y-coordinates to give you the rise, or you could subtract the x-coordinates to give you the run. In math, when we're subtracting something, we talk about the difference, and we have a symbol for difference. It's a triangle, and it means it's delta. So delta y, delta x, and that's the change in the y-coordinates, change in the x-coordinates. And these are this is called the formula for slope, or the slope formula. So in actual fact, we didn't need the graph, and then later on, in a few minutes, I'll do another example where I won't graph it first. So we know the slope in this particular case is rise of 3, run of 2, which is 3 over 2. Now, even though on the third recording I'm going to focus more on the equation of a line, I am going to touch on slope-intercept formula, because I am dealing right now with slope. And if you remember, and I'll get into more detail in the next video, the equation for a line, one of the equations of a line, is y equals mx plus b. M represents the slope, and if b, think about what b would represent. B represents the y-intercept. And if you look at this graph, we have a y-intercept. It's right here. So this is the equation of our line, and now since I have an equation, I could actually generate more points, including fractions and decimals, and so now I'm going to connect the dots. Notice you can do slope in reverse by going 2 to the left and 3 down. You always want to draw your line right through your grid. Don't forget to put arrows on the ends. You need the arrows on the end because now it's no longer discrete. It's continuous, it's linear, and now the domain and range would actually change. Domain and range now would be a set of all real numbers. And so now that it's linear, the domain would be x. It's a set of all real numbers, or if you remember, from negative infinity to positive infinity. Same with the range. Reason I'm able to now say that it's continuous is because, again, I found the equation. Without the equation, you just have a series of points. Alright, so let's go on. Again, the focus is slope. I want to talk about some other slopes, but let's do another question here. Example number 2. Find the slope between negative 2, 6 and 4, 2. Of course I could use the graph, but I want to show you again how to use the formula. If we subtract the y-coordinates and the x-coordinates, we'll get the rise and the run. Common question I get is, what order should I subtract it in? Should I go 2 take away 6? Or should I go 6 take away 2? These, by the way, are the y-coordinates. And the answer is, it doesn't matter. I'll do it both just to demonstrate it. Let's say we just want to leave it in the order it is, and we're going to go 6 take away 2. Of course, if you're going to use this as your first starting point, you're going to have to use, you have to be consistent in terms of the subtraction of the same order. You would have to go negative 2 minus 4, which is 4 over negative 6. Or, because there's one negative, let's pull it out front, negative 2 thirds, lowest terms. The other way of doing this is to subtract it in the reverse order. Start with the second point, and that's typically what this means. This formula suggests to start with the second point, but it really doesn't matter, as I'll show you. So now we're going to go 2 minus 6 for the y-coordinates, and we have to start with the second x-coordinate. So it'll be 4. Now be careful here with minus. X is actually negative. So now we have negative 4 on the top, and the bottom is going to be obviously 4 minus negative 2 is plus 2, 6. We still have just one negative. Pull it out front, and you get the same answer. Let's actually double check on our graph. Negative 2, positive 6 is here. 4, 2 is here. And we have a bit of a problem. This does not look like negative 2 thirds. But let's go ahead and instead count what the rise is. And of course you're going to see it's the same values. 1, 2, 3, 4 down, 6 to the right. So the slope of this line, if we did rise over run, is negative 4 sixths, or again, negative 2 thirds. Now, even though we have 2 points, let's say this is a line, and let's talk again about a little bit more about equations, etc. So let's connect the dots. And let's talk about parallel lines. So parallel lines run exactly alongside of this without touching it to infinity. And we talked in class that parallel lines have to have the same slope. So if I said find a parallel line, I could start anywhere on the graph, let's say here, doesn't matter. And as long as I do a slope of -2/3, or if you prefer, -4/6, you're going to end up with a parallel line. And sure enough, if I draw this, I'm just drawing a line that has a slope of -2/3. And you can see that these lines are parallel. The symbol for parallel, by the way, is arrowheads on the line. What about perpendicular? A common thought that a lot of people have, so parallel lines are the same. A common thought that a lot of people have, they think the slope of a perpendicular line, and remember, this is the symbol for perpendicular. We use it because it represents a 90-degree angle, and that's what perpendicular lines represent. They meet at 90 degrees. A common idea, like I said, is that automatically perpendicular lines are opposite. And so if your line is -2/3, a lot of people say, oh, perpendicular lines would be +2/3. But I think you can see, I'm just going to do an example here, that if I took this point and went up 2 and over 3, that quite clearly we have a problem. That angle there is bigger than that angle there. And more importantly, this angle here is not 90 degrees. So, unfortunately, opposite slopes is not enough information to make it perpendicular. What makes it perpendicular is that these values have to be flipped. And we talked about in class how if your rise is -2, your run is 3, then in actual fact, if you're going to find a perpendicular line, we're going to have to go in the positive direction, opposite, and reciprocal. So opposite and flipped, which is also called in math the reciprocal. Let's see if it works. So from this point, I'm going to go up 3 over 2. Up 3 over 2. I could go down 3 to the left 2. Down 3 to the left 2. And I'm going to draw it. And what do you notice? This line crosses both of these 90 degrees perpendicular. I want to talk while I'm looking at just lines on this graph about two special cases. What does it mean if a line had a slope of 0? Well, of course, if a line has a slope of 0, you could make 0 a fraction by putting it over 1. So if we take a point, any point, and do a rise of 0 and a run of 1, we're not rising, we're just going for a run. We're doing a run, and so we're going to end up with a horizontal line. So if the slope is 0, you get a horizontal line. So that asks the question, what if you have a vertical line? So here's a vertical line. What's the slope of a vertical line? Let's take 2 points. Whoops. Let's say here and here. Notice with a vertical line, you can have a rise, but you don't have a run. This is a major problem. 0 divided by 1 is equal to 0, but 1 divided by 0 does not make mathematical sense. And we talked a little bit about class, how if you consider this line going up, the steepest line, the biggest number there is, would be infinite. If you consider this line going down, we would say negative infinity. But we describe this as being undefined. Okay, so that's the idea behind slope, rise over run. It's called the rate of change. You can find it by using a formula. There's a couple special things you have to be aware of, such as perpendicular lines, parallel lines, horizontal, vertical lines. I think I've gone through everything here. Just go through my list. And I'm just going to finish off by going down here one more time and saying our next idea, finally, is what if I have 2 points? How do you find the equation? And I'm hoping you're thinking that we've already talked about this in today's lesson, which is y equals mx plus b. But of course, the problem with the second example is we don't have b. And so I'm going to get into more detail in my next presentation. Thank you.